Good morning, guys. Afternoon, evening, I don't know what time it is. It's morning for me. Here's a little PS I didn't get enough time to go into on my last video with weak acid, weak base problems. Here's a weak base. This is just a short clip, by the way, anyways. Here's a weak base. I can tell it's probably a weak base because it has that nitrogen with its lone pair sticking off of it. Methylamine. The amine is just the NH3, and there's the methyl. It dissociates, really hydrolyzes, breaks up water to an extent of 11.4% in a 0.03 molar solution. What's the pH and what's the Kb for this weak base? Well, let's think about what the 11.4% dissociation or hydrolysis means. It means 11.4% of this 0.03, original 0.03, creates some OH minus. Sorry, that's my cat. Jumped up on the table. Poor kitty. Yeah, so where was I? Oh, yeah. So that 11.4% of that 0.03 number is approximately 0.034. So of this 0.03, this much of that decreases, creating that amount of hydroxide ion. So if that's true, then I just take the negative log of that to get the POH, and from the POH I have the pH easily. Interesting. Well, the next step isn't quite so easy. That is, what's the Kb for that? But still, it's pretty simple. Might be helpful sometimes to think about structure. So that lone pair on the nitrogen attracts that positivity of the hydrogen ion there. Oh goodness, I forgot my positive charge. There should be a plus right there. I should change that. Darn it. Anyways, on the PDF there's a plus right there, positive charge, because the H plus leaves the OH, goes over onto the nitrogen group. Alright, darn. Forgot my plus charge down here too. Well, we know it's there. I'll change it on the PDF. So what's the deal? In the beginning I have 0.03 molar methylamine, none of this, none of this. But as equilibrium is achieved quickly, this goes down a little bit, this goes up a little bit, this goes up a little bit, and indeed I did determine how much these went up. It said 11.4%. Yeah. So that's how I found those numbers, because in essence they were given to me in the beginning, disguised a little bit. From 0.03 goes down to 0.0266-ish. This goes up, then you just go back to your definition of the constant, the equilibrium constant expression, and I was lazy here. I shoulda, coulda, woulda written CH3NH3 plus in the numerator and OH minus in the numerator, so these two in the numerator, and this is in the denominator. And indeed, Kb, well, it's a fairly strong weak base, 0.00044. Alright, thanks guys.